This is an AS statistics question on binomial hypothesis testing. Nasir is playing a game with two friends. The game is designed to be a game of chance, so that the probability of Nasir winning each game is 1/3. Nasir and his friends play the game 15 times. Part A, find the probability that Nasir wins, in the first part of Part A, exactly 2 games. Now I'm going to say what my random variable x is. This is optional, but I'm going to write down that x is equal to the number of games that Nasir wins. I just find this helpful in trying to fully understand the question. The number of games that he wins is a binomial distribution. The number of trials is 15, and the probability that he wins a game is 1/3. So we should always state what our model is for the question. I need to work out the probability that he's going to win exactly 2 games. So the number of games that he wins is equal to 2. This we can work out directly from my calculator. Now remember, we'll want to choose binomial PD on our calculator. And we'll get 0.05999460 and so on. Now when you give answers, give them to a minimum of 3 significant figures, so no less. So if I round this to 3 significant figures, I'll get 0.0599. So 3 significant figures, not 3 decimal places. You can give 4 decimal places, but 3 significant figures is like the unwritten rule. So 0.0599. Then for the second part of Part A, I need to find a probability that Nasir wins more than 5 games. So let's write down what that probability looks like. So more than 5 games. So probability X is more than 5. Now it's not equal to 5. So this is the same as saying the probability that X is greater than or equal to 6. And that in turn is equal to 1 minus the probability that X is less than or equal to 5. So we're going to work out the second part of this on our calculator. So it'll be 1 minus 0.618371 and so on. So remember, to get this value, you'll need binomial CD this time. And that gives 0.381628. And again, we'll give that to 3 significant figures. So 0.382. And I suppose I should put here that I've rounded it to 3 significant figures. And the same with my previous answer. Okay, part B. Nasir claims that he has a method to help him win more than 1/3 of the games. To test this claim, the 3 of them played the game again 32 times, and Nasir won 16 of these games. We need to state our hypothesis clearly, test Nasir's claim at the 5% level of significance. Okay, so the first thing we do when we do any type of hypothesis test, and we need to state our hypothesis clearly, is to write down what's H0 and H1. So H0 is going to be that the probability is 1/3, that there's been no change, and H1, that the probability is now greater than 1/3 because of this phrase here, more than 1/3 of his games. This part of the question is still binomial. This time the number of trials is 32. It's still 1/3. Remember, we always test H0, and we're going to accept or reject H0. So this will be always the H0 probability. And because it's greater than, this means we're going to be doing an upper tail test. And since it's an upper tail test, I want to work out a probability that he would win more than or equal to 16 of these games, and work out what that probability is. So this will be 1 minus the probability that x is less than or equal to 15. Let's work that out on our calculator, see what we get. So we've got 1 minus 0.96234 and so on. Keep that value, so whenever you do this type of thing, just go back to calculator and do 1 minus answer to get an exact value, and I'll get 0.037653 and so on. So now we've done our calculation, we compare our calculated value with the significance level. If our calculated value is less than the significant level, we're going to reject H0. If it's greater than the significance level, we're going to accept H0. So since my calculated probability 0.037653 is less than 5%, okay, we reject H0, and now we need to write a conclusion in context. So that conclusion will be, therefore, there is insufficient evidence to support NASIR'S claim. Now we don't need to state that claim because it's already stated in the question.